Okay, loose. This is what we did a second ago. Let's go large on that, right? So number lines: greater than 4, greater than or equal to 3, less than -1, less than or equal to 2. Take note of what I said here. If you're greater than or less than, then that number is not included. If it's greater than or equal to, less than or equal to, then that number is included, as seen by the filled in circles as opposed to the excluded unfilled in circles. Ditto for that, for these little compound inequalities or composite inequalities or sandwiches. 4 and 8 excluded, 3 included, 5 excluded, etc. So you've got this coming your way. Solving inequalities, like I used to say many years ago, treat them like equations and they will love you. All right, so again we talked through this. Again, just the inverse operations: take the 5 over, subtract, get 6 divided by 2, c is less than or equal to 3, and we tested out that these two actually work by taking the example you gave me. So you chose a number less than 3, and I think you chose 2, and 2 times 2 is 4, plus 5 is 9, and 9 is less than 11. So again, it works. So went over those 4. Here I've tried to convince you that you simply cannot divide by a negative value in an inequality. But instead you need to manipulate the inequality to make sure that what you finally do divide by won't be negative. So what I did was to take my -4a term to the other side and subtract. So I really have got 0 is greater than 8 plus 4a. Then I can subtract the 8 to the other side. So I've got -8 is bigger than 4a, and then write it around the correct way. 4a must be less than -8. Dividing by 4 gives us -2. So that works. So a is less than -2 is correct. A is greater than -2 is not correct, and logic dictates that they both can't be correct and they can't both be wrong. But again, by example, we've shown that this is wrong and similarly that this is correct. Okay, solving inequalities where the unknown is in the middle of the two ends, so to speak. You've understood that we added 10 to each side, then divided by 3, and the permissible solutions as integers will be 3, 4, 5, but not 6, because x has got to be less than 6. And here's another one that we did, taking the 2 over to each side and subtracting, then dividing by 3, the permissible solutions being anything greater than -2. So -1, -1, 1, 0, 1, 2, and 3 is included. It says less than or equal to. What's this? Okay, there's another one. Multiply out the bracket, subtract 15 from both sides, then divide by 3. So we've got 6 and 2/3 is less than the value we're looking for, and the value we're looking for is less than -5. That's the correct solution. And if you're having to quote the integer solutions or solution, well, the only one we worked out that works is -6, because -6 is bigger than that because it's closer to 0 going that way, but you're not allowed to be -5. So -6 is the only solution. And then I said you have got to do exercise 10.5 skills, page 203, all of question 2, all of question 3. And the main reason I'm doing this is so that you can see this in the video. So when you get this on your laptop or some other device, you pause your video and you do those questions. All right, I will give you answers when you've done all that. You will check all this yourself. Where are we? You will check that little lot. And again, any mistakes, you talk to me. There could be mistakes in the answer book. Remember, these books were produced in a huge hurry, and that meant that there were mistakes in the answers and occasionally some of the questions which just don't even work. So, okay, so that's that again. And now I want to sign off.